Students, welcome to my YouTube channel ScopeIIT. Today we'll discuss about the topic adder. Okay. Now what do you mean by adder? Adder basically is a combinational circuit that performs the arithmetic addition of binary numbers. So adder, that means add. Okay. So which operation it will perform? It will perform the addition operation. Okay. Now basically there are two types of adder. One is your half adder, another one is your full adder. Okay. Now what do you mean by half adder? So we'll see. I'll explain you with one block diagram. Now see, half adder. What do you mean by half adder? Half adder, that means basically it will have only two inputs. What do you mean by half adder? The adder which takes only two input. Okay. So that is what, if I'll give example A and B. Okay, this is a half adder which will take only two input, and as it is add. Okay, so what will be your output? Your output will be one to sum, because it will give you total, right? Sum. And another output will be carry. Correct, carry is also possible. Okay. Now if we will talk about full adder, okay. If we will talk about full adder, then how many input full adder will take? Full adder will take three inputs. That is A, B and 3. Okay. So full adder will take three input and output will be same. Okay. Input is more than that also, output is same. That is sum. That is sum and carry. Okay, your output is same in that case. Understood? So that is the main difference between half adder and full adder. Half adder, that means it will take only two input, whereas in full adder it takes three input. Okay, so we'll understand this both technique in detail. Half adder. Half adder basically is a combinational logic circuit that adds two single binary bits and produces the sum and carry. As I told you, what do you mean by half adder? Half adder, that means it will take two input and it will produce sum and carry as an output. Okay. So first of all, we'll draw the block diagram for the half adder. Okay, as I already explained in the beginning, same only. What do you mean by half adder? Addition of two. Okay. So see, the block diagram of half adder will be like this. It will take input as A and B. Okay, only two inputs. And in the middle we should write HA. HA means half adder. And your output will be sum. Your output will be sum and carry. Okay, so this is the block diagram you have to draw for your exam. Afterwards you need to draw your truth table. So we'll draw here truth table. Okay, now see here. So here how many inputs are there? Two inputs A and B, and outputs are sum and carry. Okay, so here we will write A, B, then here sum, and last here carry. Okay, now as you can see that what it's taking how many input? Two inputs. Okay, so in digital logic, if there are two input, then I already explained what is the possibility: 0, 0, 0, 1, 1, 0 and 1, 1, right? So the same thing we will write here: 0, 0, 0, 1, 1, 0 and 1, 1. Okay, now sum. What do you mean by sum? You need to perform binary addition of this and this. Okay, so 0 plus 0, what is the sum? Sum is also 0, carry is also 0. Then 0 plus 1, in that case your sum is 1, your carry is 0. If we talk about 1 plus 0, 1 plus 0, sum is 1, carry is 0. See, if you're having doubt with this binary addition, in my previous video I've already explained binary addition. You can go through that first. Okay, then 1 plus 1, 1 plus 1, in that case your sum is 0 and your carry is 1 in that case. Okay, now after doing this we need to generate the characteristic equation for this one. Okay, so what is the equation for half adder? So see how to get the equation for half adder. Now here output are two, right? Sum and carry. So first we will get the equation for sum. So what is the equation for sum? See, now here in sum column, just we will see this column. Okay, just we will see this sum column. In this sum column, where you are having one here and here. So take it horizontally. For this first one it will be this one, for second it will be, okay. And I already explained in many videos that 0 means bar. Okay, 0 means A bar and 1 means no bar. There will be no bar. Okay, so it's having 0. So 0 and 1. So what will be the equation? The equation will be A bar B. Okay, for this one. Then what is the equation for the second one? A B bar. Why? Because 0 is for B. So B bar. Okay. So it will be A bar B plus A B bar. Okay. And basically A bar B plus A B bar, that is nothing but this is the formula for A XOR B. Okay, this is the formula for A XOR B basically. Okay, you have to learn it. If you don't know, you can make a note here, right, in your notebook, that A bar B plus A B bar. This we will use at many places, okay. A B bar, that is nothing but equals to A XOR B. This is the formula, okay. Next is carry. Now how to get the equation for carry? In carry there is only one, okay. Then here there is no bar needed because both are 1, okay. So what is the equation for carry? Equation for carry is nothing but AB. Right. Now after writing the equation, we have to generate the circuit diagram for this one. So here for sum we need one XOR gate, and for carry we need dot means AND, okay. So for carry we need one AND gate. So we'll draw it here. So first of all for XOR, okay. So one XOR gate I'll draw. Okay, and this XOR gate will produce sum, right? Output sum. Okay. Then I'll draw one AND gate. And this one AND gate will generate what? B, right? Now see here. For this sum, okay. For this sum, what is the input? A and B will go to XOR gate. Okay, so I'll take input as A and B, right? So A and B will go in this one XOR gate. So it will produce A XOR B. Okay, and in this one, sorry, here I've written B, no, it should be carry. Okay, so this is your carry. So in this AND gate, what will be the input? Here also the input will be what? A and B only, okay. So from here only I'll take one arrow for A, and from here I'll take one arrow for B. So this is the circuit diagram for half adder. Okay, so in case if they'll ask you about half adder in your university exam like BCA, MC or any engineering, right, then you have to write this much. Okay, this theory, then this circuit diagram, equation, truth table, this much you have to write for half adder. Now full adder. What is full adder? Full adder is a combinational circuit that adds 3 input and produces 2 output, right? So I already explained you for half adder how many input will be there? 2 input, whereas in full adder there will be 3 inputs, okay. Now see, so this is the block diagram for full adder, FA, that is full adder, and there will be 3 inputs, right? That is A, B, C, I'll take A, B, C. So these are the 3 input that will go to full adder. And output will be sum and carry, that is same, right? Okay. Next we'll construct the truth table for full adder. Okay, now see. So as there are 3 inputs, so we'll write here A, B and C. Okay, and what are the output? Your output is sum and carry. So the same thing we'll write it here, okay. Now, as now there are 3 input, okay. So how to write it in digital logic with 3 variables? You already know it, right? So there will be 4 zeros and 4 1. After that 2 0 and 2 1, okay. Next is 0 1 0 1. Okay. Now, if we'll talk about sum and carry, okay. So for all 0, your sum is also 0 and carry is also 0. Okay, if it is 0 0 1, then in that case your sum is 1, your carry is 0. Okay, this I am doing is normal binary addition. Okay, if you are not aware of it, you can watch my previous video. I have already explained you binary addition. Okay, next is 0 1 0. Okay, and see how to do it. So see, 0 plus 1 is 1. Okay, and 1 plus 0 is again what? 1. So in that case your sum is 1 and your carry is 0. Okay, the next is 0 1 1. 0 1 1, in that case your sum is 0 and your carry is 1. Okay, then 1 0 0. 1 0 0 means your sum is 1, your carry is 0. Then again it's 1 1. 1 1 means sum is 0, carry is 1, again 1 1. So sum 0, carry 1, and all 1. All 1, that means sum is also 1 and carry is also 1. Okay, so this is the way we have to do. Now, how to write the equation for this one? Okay, so the equation for sum. Okay, so the equation for sum. Now here where you are having 1, you are having 1 here. So if we take it horizontally, it's 0 0 1. So a bar, see, I already told you, right? 0 means bar, 1 means no bar, right? 1 means no bar. So the same thing, it will be a bar, b bar, c. So it will be a bar, b bar, c, plus next will be what? 0 1 0. 0 1 0, that means a bar, b and c bar, right? Plus next you have 1 here. So that means a, b bar, c bar. So it will be a, b bar, c bar. Okay. Next last you have 1 here, all 1, right? So it will be plus a, b, c. Now see, actually if you will solve it, then it's a very lengthy processor which is not required for your university exam, either BCA, MC or engineering exam. Okay. So after writing this, you can directly write it down A XOR B XOR C. Okay, so if you will solve it, you will get this equation. Okay, and otherwise, if you want, you don't need to write this also. Directly you can write the equation for sum is A XOR B XOR C. Directly you can write it down. Okay, but if you want to write this, then you can even write this also. Okay, then next, what is the equation for carry? Okay, so the equation for carry. Now in carry, where you have 1, you have 1 here. Okay, so that is 0 1 1. So that is A bar BC. Plus next you have 1 here. So that is A B bar C. So it will be A B bar C. Plus next you have 1 here. That is A B C bar. A B C bar, right? Understanding that this one I am writing, this one. So 1 1 means A B, 0 means C bar, okay. Then plus last is all 1. So it will be A, B and C. Okay. Now here also you remember the final equation for carry. What is the final equation for carry? That is your AB plus C in bracket A XOR B. A XOR B. Okay, so this is the equation for carry and this is the equation for sum. Next we need to construct the circuit diagram. Okay, so I'll change the page in this one, it's not possible. Okay. So first I write the equation, based on that I'll tell you how to construct the circuit diagram. Okay. So for sum the equation was A XOR B XOR C. Okay, and for carry the equation was AB. If the thing is that means dot, okay, and operator, plus C in bracket A XOR B. Okay, so this is basically the equation for this one. Okay, now how to draw the circuit diagram? So if you will see this properly, okay, so A XOR B, okay, here also you have A XOR B, okay, so I can draw like this. First I'll take one XOR gate. See, first I'll take one XOR gate. Okay, then in this XOR gate I'll give input as A and B. Okay, only the input is A and B. So in that case this will generate what? A XOR B, right? Because it's going to XOR. Okay, then after that if I need for sum, okay, if I need for sum, okay, then what I'll do, I'll add one more XOR gate here. I'll add one more XOR gate here. Okay, now I want here A XOR B XOR C because I want for sum. Okay, so I'll take this as an input. Okay, so that is A XOR B, and I'll take C as an input here. Okay, so now it will become what for sum? A XOR B XOR C, right? XOR C. So this is the equation for this one. Okay. Now next we need to generate the equation for carry. Okay. So if you will see carry, how many AND gates are required? So see, one AND gate is here, one AND gate is here. Okay. So we need here two AND gates. So first of all, I'll draw two AND gates. Okay. Then this both AND gate is connected with what? Plus. That means one OR gate. Okay. So I'll draw one OR gate here. Okay, so I'll draw one OR gate, and this will finally give you the output as carry. Now what will be the input? So the input in first AND gate is nothing but A and B. Okay, so take line from here. Take arrow from here. So this A will go here and B from here, right? So this will generate basically AB. Okay. Then next in this AND gate, what I need? One I need A XOR B. Okay, that's why I wrote here separately, right? So I'll take one this A XOR B here. Okay, what else you need? You need one C, right? So I'll take a line from C also. That's all. Okay, so this is all about the circuit diagram for full adder. In complete detail, I have explained you this point. Okay, so this topic is very important for your university exams. Okay, if they'll ask you full adder, okay, then you have to write this much: the definition, your block diagram, your equation. See, equation, if you people will write directly, no, this one. Like sum is equals to A XOR B XOR C, and carry is equals to AB plus C in bracket A XOR B. That is also fine. Okay, if you will not write this, that is also fine. Okay, then you know you have to draw the truth table, and finally you have to generate this circuit diagram. So this is all about your half adder, full adder. Okay, if you like my video, please like and subscribe my channel. Any doubt is there, you can ask it in comment. I'll answer it. Thank you.